An ionic bond is a type of chemical bond formed through an electrostatic attraction between two opposite charged ions. Ionic bonds are formed between a cation, which is usually a metal, and an anion, which is usually a non-metal. The larger the difference in electronegativity between the two atoms involved in the bond, the more ionic the bond is. One example of ionic bonds is CaCO2, which is calcium cobalt. In ionic bonds, one atom gives electrons to the other one so they can attain the noble gas configuration. A covalent bond is a form of chemical bonding that is characterized by the sharing of pairs of electrons between atoms. And usually, covalent bonds are non-metal reacting with a non-metal. One example of covalent bonding is carbon dioxide, which is CO2. Lewis dot structures are diagrams that show the bonding between atoms of a molecule and the lone pairs of electrons that may exist in the molecule. Lewis structures can be drawn for any covalently bonded molecule as well as coordination compounds. Lewis structures show each atom in its position in the structure of the molecule using its chemical symbol. Lines are drawn between atoms that are bonded to another pair. Pairs of dots that can be used instead of lines. Excess of electrons that form lone pairs are represented as a pair of dots and are placed next to the atoms. Although many of elements react by gaining, losing, or sharing electrons until they have achieved a valence electron shell configuration with a full octet of electrons, there are many noteworthy exceptions to the octet rule, like hydrogen, which only needs 2 electrons to get the octet full shell. How to name and write chemical formulas. First, identify the symbol of the cation, first part of the name, and the anion. Second, identify the valence or the charge of each symbol and placing it in the parentheses just above the symbol. Third, balance the total positive and negative charge on the cation and anion. Just ask yourself to do the positive charge and total negative charge add up to 0. If the answer is no, then we ask how many of each ion we have in order to balance charge. We must have the same number of positive charges as we do of negative charges. Another way of saying that is they must add up to 0. 4. Once you have determined the number of units of the cation and anion, those become the subscripts which are placed right after their respective symbol. So for example, what is the formula of copper 1 oxide? First, identify the symbols of the cation and anion. Copper is Cu and oxide is O. Second, identify the charge for each and place above the symbol in the parentheses. For copper 1, that will be +1, and for oxide, that will be -2. Balance the positive and negative charge. Since each copper is 1, +1, and each oxide is -1, then it will take 2 Cu plus to balance 1 oxide with a 2 negative, so that 2 parentheses 1 plus 1 parentheses 2 negative equals 0. The numbers outside the parentheses become the subscripts in the formula. 4. Write the formula placing the subscripts right after the symbol they go with. So, Cu2O. Valence shell electron pair repulsion rules are a model in chemistry used to predict the shape of individual molecules based upon the extent of electron pair electrostatic repulsion. The premise of VSEPR is that the valence electrons pairs surrounding an atom mutually repel each other, and will therefore adopt an arrangement that minimizes this repulsion, thus determining the molecular geometry. The number of electron pairs surrounding an atom, both bonding and non-bonding, is called a steric number. Molecular geometry or molecular structure is a three-dimensional arrangement of atoms that constitute a molecule. It determines several properties of substance including its reactivity, polarity, phase of matter, color, magnetism, and biological activity. Example of ionic bonds is CaCO2, which is an ionic bond formed by calcium cobalt.